Good morning, one and all. So, in last class, we have discussed regarding elective called the design concepts of building services. So, in that subject, we are going to concentrate main on building components, and at the same time, we are going to concentrate what are all the basic requirements of the buildings are there, and then how to manage those building requirements in a orderly development of the society. At the same time, we have to give services. We have to give the proper service to the building as well as the building components by satisfying the basic needs of the buildings. Okay. So, that part we have discussed in detail in last class. Then we have discussed regarding 5 models. So, each model indicates their own involvement within the subjects. That part we have discussed in detail in last class. So, in today's class we are going to concentrate with module 1, that is water supply, drainage and waste disposal. So, now we need to concentrate more on water supply first, then how once the water supply, water is used, of course, it is become a waste water, that is drainage, how to convey that drainage to the main streamlines, I can say, and then finally it will be end up with some storage tanks, so that it's better to treat it at that particular place, so that once again we can send that water to for gardening purpose or for cleaning purpose or for industrial purpose, something etc., I can say. So that we can have water, we need to match the water demand also. Okay. And at the same time, waste disposal, how to dispose the waste. We should not supposed to dump it directly to the nature or directly to the main streamlines, I can say. So, we should be treat it first, then we need to dispose it to other places, I can say. Okay. So, that part we are going to discuss in detail in our upcoming classes. So, in the foremost important thing is water supply. First we need to understand, of course, water is a main materials, I can say. We can't specifically say it as a material, it is a main thing required for human beings. Yes or no? So, after air, so water is the second most important thing in this world, I can say. Without water, of course, human can't survive, even animals can't survive, I can say. Okay. So, at the same time, how to give suitable water supply to a public, that is very important thing. Some other places, some other comments takes place, so why can't we drink rainwater directly? Yes, but as the discussion said, in turn we have some atmospheric variations, we have some acid rains, or we have some acid contaminations within the water supply, so that it will in turn give some diseases, or the health will going to upset, or something will going to create in their own body, I can say. That is why we should not supposed to drink rainwater directly, and at the same time we need to store it at certain places, at suitable places, I can say, and we need to treat it. And at the same time, of course, river water is good for drinking, even well water is also good for drinking. At the same time, we need to treat them. After treating only, we need to give water supply to the domestic purpose. So, before going to concentrate on treating process of water supply, first we need to understand their requirement. Yes or no? So, water supply, if you want to supply the water, first we need to understand what should be the demand, what is the quantity of water we are going to supply to a building. That is very important thing here. Yes. So, once we need to calculate the water requirement for the buildings or water requirement for the public. If I consider one house, so what should be the water quantity for that particular building? If I consider one village, what should be the total water quantity required for that village? Similarly for taluka, similarly for that city, town, district, so that I can concentrate what should be the consumption of water for that particular area. How we are going to calculate water requirement? Yes, we know the simple technique called quantity of water is always equals to per capita demand. Per person, what is the consumption or requirement of water multiplied by the population. For example, if I consider my own house, I have around 4 members in my house. So, each person will consume some lump sum amount, will have some rounding value. It might be 100 liters, 135 liters, 200 liters or 50 liters, depends upon the criterias. Whether it's in metropolitan cities, I can say, then the water requirement will be vary. If we have village region, the water requirement will be vary. If we have at middle range, I can say, some towns or cities or some layouts, then the water requirement is different. Depends upon our comfort zone, depends upon the usage of the public, the water requirement or water demand will once again going to vary. Then how the water demand will going to vary? Of course, the population will remain same. For example, if you have 20,000 population in one village, so for 20,000 multiplied by per capita demand, that indicates how many liters of water required per person per day. Yes. Once again, according to IS 1172/1963, we have the water requirement for different regions. If the domestic purpose of 20,000 and below or up to 20,000 population, the water requirement is going to vary. Yes, that is around 40 LPCD I can say. Similarly, for water requirement for the population above 20,000 to 1 lakh, then the water requirement is around 70 to 100 liters per day I can say. Yes, similarly if the population exceeds 1 lakh, then the water requirement is once again going to increase by 150 plus 150 to 200 LPCD, because they have their own comforts. For example, if I consider Mysore city is an example, of course the water requirement is not only for drinking purpose I can say. Even though the water requirement we are going to concentrate is for domestic, within that domestic purpose we have n number of subdivisions I can say. For drinking purpose we need water, for bathing, for cleaning, for cooking, then for cleaning or washing the utensils, for gardening purpose we need water, for cleaning purpose we need water. Yes or no? So we need to categorize these subheadings into domestic purposes. So for household person, what should be the water requirement? Yes or no? So before going to concentrate that part individually, right, first we need to understand how to calculate the quantity, that is per capita demand of water multiplied by the population of that particular area, which will give you the total requirement of water for that particular building. If I consider building as an example, of course per capita demand around 135 LPCD according to IS code, and then population is around 4 members. So per building, so around so and so liters of waters will require. Yes, if similarly we can go ahead with one apartment, we can go ahead with one area, we can go ahead with one township, something like that we need to add up. According to this water requirement, we are going to construct the overhead tanks or underground tanks to store the waters. So for example, we will usually heard the tendency called let us construct a 1 lakh liters capacity of water tank, that is overhead water tank. That 1 lakh liters capacity is once again designed according to these principles. So that locality, area of that population, okay, that too we are going to calculate it for future decades. We should not supposed to have only one decade or present decades I can say. Okay, so present year there are some around 10,000 population is there for one particular layout I can say, but after 10 years that populations will not remain same as 10,000 I can say. Of course, it will increase by some extent. Yes, there are some suitable methods or techniques are there to calculate the population forecasting process. So according to that, we need to calculate the water requirement for future decades, around 10 years, 20 years, 30 years. Next 30 years, what should be the requirement of water? On that principles, we need to construct the overhead water tank, right? That is for domestic purpose I can say. Then the types of demands. Just now I have discussed regarding how the water quality or water quantity we are going to calculate. Okay, of course, it's a simple technique. Then coming to types of demands. Demands will not remain the same, because according to the comfort zone of public, the water requirements will also going to vary. For example, the first and foremost thing is domestic purpose I can say. For household requirement, the water demand is going to vary. That is first one, domestic. Then the second one says something about the industrial requirements or industrial demand. Then the third one says something about institutional and commercial demands. Then the fourth one is demand for public use. Then fifth one is fire demand. And lastly, losses and wastes. Yes, these are all the basic types of demands for water in our day-to-day activities I can say. Even if we can start with a simple township to a metropolitan city, these requirements are compulsory, but their extent of requirement may going to vary. Of course, industries, we may not come across some huge industries in village region I can say. Yes or no? But there are some provisions made in village region, because next futuristic plan, there might be some addition of some small scale industries I can say, or medium scale industries I can say. Of course, we require some water for that. So we need to plan those things before going to forecast these parameters. Okay. So first we will discuss one by one. Okay. So first we will take domestic water requirement. So if I come across domestic concept, so what are the basic subheadings are required in domestic water requirement or domestic demand I can say. Of course, the first one is drinking purpose. So according to IS code 1172, it says that for drinking purpose 5 liters per day per person is required. Yes, so 5 liters per day for drinking purpose. Then cooking, for cooking purpose we require once again 5 liters per day. Yes, then for bathing we require 55 liters per day. Then for washing 20 liters per day. Then washing utensils we require 10 liters per day, and for house cleaning or household requirements we require 10 liters per day. So all together, so domestic purpose we require around 135 LPCD, that is liters per capita per day. All together it will come around 135 LPCD. For example, now we can concentrate here. If we have 4 members in a building, right? So 4 multiplied by 135, we come across what should be the water requirement for my building or my house. Similarly for my area I can calculate. Similarly for that whole town I can calculate. Yes, according to that I need to check it out what should be the supply. Yes, for example in Mysore city, if you want to supply the water from KRS, of course we need to decide what should be the total requirement of water according to these principles. It is only for domestic purpose. I have not incorporated any institutional, commercial, etc., etc. Okay. So according to IS prescription, I can say 135 liters per day per capita will be the requirement for domestic purpose. So that is domestic demand. Then coming to industrial demand. Yes, industries are the backbone for the city I can say, because the city is said to be growing in a very good manner, or the city is in right direction, or the city is in progress I can say. Of course, we must come across industries, whether it might be a small scale industries or large scale industries or medium scale industries. Once we are going to develop that industry entrepreneurship skills in our public mentality I can say, then only we can have some industries. Once the industries are grown, of course we can get some revenues to the society I can say. Of course the overall development will going to take place, as well as the human's comfort zone is also get improved, our lifestyle is also get improved. So of course our knowledge is also get enhanced at some extent I can say. Okay. So by considering these parameters, industries are going to play a major role, right. At the same time, for industries which is not supposed to directly starts with industry, it might be of any industry I can say. It might be a paper mills, it might be a cotton mills, it might be a rice mills. You can take any example. It might be of any industries. It might be of raw materials manufacturing industries I can say, or it might be some production of any materials I can say, or it might be assembling of those materials I can say. So every industry, water requirement will play a major role. Once again, within that industry, we need to divide that entire requirement into subheadings. It might be once again drinking purpose, washing purpose, cleaning purpose, then cleaning the floors, okay, then cleaning those instruments, huge equipments, or for mixing purpose of any raw materials also we require water. Yes or no? So these are all the requirement of water for industries. So according to once again codal provisions, around 20 to 25% of the water, that is 20 to 25% of the total water requirement is dedicated to industry. Yes, that is industrial demand I can say. Then coming to the next point, institution and commercial. Of course, without institutions we can't say the country or village or any area is get developed. Yes or no? Because education will play a major role in our life. Yes or no? So we need to impart education to our youngsters. At the same time, we need to construct some buildings, that is institutions or some what we can say schools, colleges, universities, etc., etc. Once again, those buildings require some waters. Yes or no? And that too, there are mass students are going to gather at one place. That automatically the consumption of water is also got increased. Yes or no? And at the same time, commercial. We want, of course, we need to sell and purchase the things. So for selling and purchase, once again we need some buildings, that is for services purpose. It's nothing but the commercial activities purpose, I can say. Once again for commercial, once again it depends whether it's a small scale or large scale or medium scale. We are going to construct a shopping malls or we are going to construct just a stores. Depends. Once again water requirement is there for both the buildings, but it depends upon the requirement, the quantity may going to vary, but the concept remains same. That's why in institutions and commercial requirement, yes, they are going to play a major role in water requirement calculations, I can say, because finally we are going to add the requirement of all the parameters. It might be domestic, industries, institutes, public use, fire, losses, everything we need to add together, and finally we need to arrive. So what should be the total quantity of water required for buildings, right? So demand for public use. Demand for public use in turn consists of the water requirement for parks, playgrounds, gardens, then cleaning the roads or cleaning the city. Yes. So these are all the requirement come across demand for public use, and generally we are going to reserve 5% of the total requirement of water is for public demand. That is for public use, I can say. Okay, demand for public use is reserved around 5% of the total water requirement. Okay. So coming to the next point, fire demand. Of course, nowadays we are planning that the building should be fireproof. Yes or no? So everyone think in that manner, but fortunately or unfortunately, we can't say all buildings will 100% give resistance against fire. We can't say, or we can't able to construct like that. But at the same time, we can say something, it may avoid some major issues come across fire. Yes or no? Because once the fire catches, so that the persons within that building, they must go out. Okay. So we need to call a fire stations. So then they will going to minimize the fire catches process. Okay, by sprinkling the water. Once again, this is an emergency concept, I can say, but even though there is some requirement for fire demand. Yes or no? So according to Cushing's formula, we can say quantity calculation or quantity of water required for fire demand is 3182 into root P, where Q is the total quantity of water required for fire or fire demand, then P is the population in terms of thousands. Yes, for example, if for one cities, so around 10,000 or 20,000 or 100,000 population is there. Okay, that root of that population multiplied by 3182 will give you the total water quantity required for fire demand purpose, I can say. Okay. Then the next point says something about the losses and wastes. Of course, we can't say that the losses is of minimum or we should avoid the wastage completely. Yes or no? Okay, but in practice, practically speaking, there are some losses takes place. It might be due to the fittings of pipes, I can say, or the defective pipe fittings, I can say, or it might be leakages at joints, or it might be wastage due to what we can say non-cohesion between two pipes, or they are not properly maintained, or if the maintenance is not good, once again there are some leakages takes place, and that all comes under the losses and wastes. So an allowance of 15%, right? An allowance of 15% is reserved for losses and waste purpose. Total quantity required, the total water quantity required, in that 15% allowance is reserved for losses and waste, because we can't predict it out. Because of some bend in pipes, there are some wastage of water takes place, or if the water pressure is got to increase, there are some wastages takes place. If any or what we can say converging of pipe, there are some water losses will takes place. If the diverging of pipes, there are some water losses will takes place. If certain water currents or water hammering takes place, there are some wastages of water takes place. So to compensate all these things, regular maintenance of these water pipes is very, very important, as well as those fixtures. We need to concentrate that part also. Okay. So, all together we need to reserve around 15% of the water, that is 15% of the total water requirement is for losses and waste purpose, I can say. So, all together if we add all together, it will come around, see we have already discussed for domestic purpose we have 135 liters per day, yes, for domestic 135 liters. Then for industrial purpose, for industry we can have 40 LPCD. Of course, this is already 135 LPCD, right. Then for industries we have 40 LPCD, and for public use, that is demand, public demand 25 LPCD, and for institutional buildings we have 25 LPCD. Similarly, for fire we have 15 LPCD, that is per person per capita per day, I can say. Then for losses and waste around 55 LPCD. So, by adding domestic, industrial, institutions, public demand, fire as well as losses, so you may come across around 295 liters per capita per day on an average. Approximately we can say 300 liters per capita per day will be the total requirement of water for these many demands, I can say. Okay. By considering all these demands, we require around 300 liters per capita per day. If we have around 1 lakh liters, 1 lakh population, so 300 into 1 lakh, that much of water is required for all these demands, I can say. Yes or no? So, this is how we are going to calculate, or we are going to come across how water quality or water quantity requirement concept, I can say. Okay. So, in upcoming classes we are going to discuss something about the impurities, or what are all the techniques are there to remove the impurities within the water. Okay. Thank you.